Okay, so here's what we'll do, real quick. Have a look at this, please. Gotta be quiet. Need things put away. Phones away, please. All that kind of stuff. Earbuds, phones, any kind of distraction. Okay, what I want to do, I'm just going to get right to the algebra part of this, and maybe we'll spend, at some point later in the year, we'll come back and kind of talk about sort of why this stuff is the way it is. But for now, I don't really want to do that. I want you to focus on being able to do three things. One of them we've already talked about. If you go back to, this is your handout. I want you to be able to solve absolute value equations and both kinds of inequalities. So let's go back and let's kind of review very briefly what we talked about earlier this week, late last week. We already talked about what we do when we want to solve an absolute value equation, right? Remember what our strategy was. We're solving an absolute value equation. There's really two parts to this. We want to get we got to make it look like this. We've got to get the absolute value bars by themselves on one side of the equation, and then those are equal to some number. When I get it to this point, then that's as far as I can go with absolute values, and I have to make a trade, right? At that point, I'm going to make a trade of one absolute value equation for two regular equations, right? And it's a really simple thing that we're doing. All we're going to say is the argument of the absolute value, meaning what's inside of it, we're either going to set equal to c, or we're going to set it equal to negative c, and that just gives us two simple equations that we can solve, okay? No big deal. Let's look at a quick example of that. So, something like this. Okay, so can I make my trade yet? I can't, right? That doesn't quite look right yet. It doesn't yet quite look like that, does it? Right? What do I have to do first before I can make my trade? Yeah, I've got to get rid of the 8. I've got to get the absolute value bars isolated, right? I've got to isolate the absolute value, and then I can make the trade. So there's one step there. I heard it. What was it again? Add 8. Good. Add 8 to both sides, right? And that's going to give us what? We're going to get on the left side just my absolute value, and on the right side 15. Okay, agreed? Okay, so now we've got it where we need it. We've got our absolute value equal to a number, so we can make the trade. Whatever's inside the absolute values, so all this stuff, and I don't even want to focus on what that is yet, right? Whatever is in there, just call it the red bubble. The red bubble either equals what? 15, or the red bubble equals negative 15, and now we can just go take those two equations and solve them. And either way, I mean, they're going to be, from this point on, it's pretty easy, right? Yeah. What are the steps I go through to get the x by itself? Over here. First, I add 12. So I get what, 27? Now what? By what?
Negative.
Not 3. Negative 3, okay. So I get x equals what? Not 7. 9, there we go. Negative 9. Okay, if I do the same thing over here, if I add 12 to both sides, everybody agree? If I add 12 to negative 15, I get negative 3. Divide by negative 3. And what do I get? 1. Okay, so that's my answer. X equals negative 9 or x equals 1, right? If I go back to Moodle and I input that, Moodle just wants, it just wants me to put, if multiple solutions exist, just separate them with commas. So what are they again? Negative 9 and 1?
Yep.
So negative 9, oops. Negative 9. Oh, I saw that. Is that negative? There we go. Negative 9, comma, 1. That works. Okay? Yeah.
I have a question. So when it's like the absolute value, like, doesn't it just become like 3x? And
No, it doesn't, because,
okay.
now it's a good question. It's a good question. So
I was just confused.
let's take an easier one for a second. What if we did something like this? What if I said the absolute value of negative 2x equals 10, right? Okay, now think of what a solution, we probably could just come up with those solutions without even going through the whole process. One of them would be 5, wouldn't it? Right? Does that make sense? Because -2 times 5 is -10, and now I take the absolute value. The absolute value of -10 would be 10. So one answer is going to be -5. The other answer would be, or would be +5. Sorry, the other answer would be -5. Because -2 times -5 would be +10. Absolute value of 10 is 10, right?
Okay,
And so, does that make sense?
Oh, okay. Yeah.
So it's going to change the solution, isn't it? If I made those positive, if I made that positive 3x plus 12, I would get different solutions to the,
Okay.
see what I'm saying? It would require different values of x to give me numbers whose absolute value would work then.
Okay.
Okay? Yes?
Didn't that used to be a thing though, like with those absolute value of didn't you always change it to positive?
Okay, yes, you do, but, okay, but that's, you're right. The absolute value of a number is equal to its positive, right? But if I want to do something like this, what if I have the absolute value of x minus 1 equals 7? Okay. What are the values that would work there? I could put in an 8, right? X could equal 8, or what else? Like negative 6? -6 minus 1 is -7. If I applied the absolute values and made that positive, for example, it's going to change the solutions that work. You see what I'm saying? So we're not going to, whenever we have an expression in there that involves variables, kind of the short answer to both those questions is, whenever you've got the absolute value of an algebra expression, it's got variables in it, then you can't change any signs. If I'm taking the absolute value of a specific number, yeah, then I can evaluate that, right? But this is an algebra situation where we're trying to solve for all the values of x that would make that expression true.
Alright, because it's like already equal to like a certain number. Like,
Right,
you
because
don't
it's
have to
already
find it,
equal to
so
10,
you don't-
exactly.
okay.
Yep. So we already know what the value is. We got to find the values of x that would work, right?
Yeah,
Okay?
that makes sense.
Yeah, good question. All right, so moving on then, the next issue is dealing with inequalities. Okay, so inequalities, fortunately, are very similar. Okay, if we deal with an inequality, absolute value of an inequality, it looks almost the same. Like for example, let's take this one. If I have the absolute value of some expression, algebra expression, is less than a number, we're going to do the same thing we did before. We're going to make a trade, only this time we're making a trade for 2 inequalities instead of 2 equations, right? And this is the part you have to kind of just remember though. If you're taking the absolute value of something is less than a number, then that's going to turn it into an and inequality. And there's kind of a reason for this that I'll just briefly describe. We'll go into more detail later. But an absolute value means a distance from the origin, right, or distance from something. If I say, for example, would you agree that if I say the absolute value of x, well, how do I do this? If the absolute value of x is less than 3, what kinds of numbers would work? 2 would work. What else would work? Well, there'd be a bunch, an infinite number, but let's pick some convenient ones that would work. If I were to graph this, so let's say that's 0, let's mark all the numbers that would work. So you told me 2 would work. What else works? 1 works. What else? 0. What else? Say it again. -5 wouldn't work because the absolute value of -5 is 5. It's too big. -2 would work though, and -1 would work, right? In fact, if we were to graph all the values that would work, wouldn't it be everything up to, but not quite including 3, everything down to, but not quite including -3, right? So it looked like, whoops, I did it wrong. So it looked like this. Right? Okay, so what's that mean? If we're talking about an inequality or an absolute value being less than something, we're talking about a bounded interval, something that's going to be bounded on both ends, right? We're talking about values that are smaller than that value, right? Okay? What if we were to change that now? Let's do something very similar. What if we did the absolute value of x is greater than 2? Okay, let's graph those in red. What are the ones that would work there? Give me an example. Let's make it greater than or equal to, how about? 2 would work. Okay, so that works. What else works? 3, somebody said, that works.
1.
Does 1 work?
No.
No. 4 works.
5.
In fact, everything out there is going to work, isn't it?
Yes, it is.
Right? But there's some other stuff.
-2.
-2 works. What else? -3 works, and -4 works. In fact, everything out there works, right? So what does that end up looking like? If you've got a situation where an absolute value is greater than something, meaning the number's more extreme, it's either going to be more positive or more negative than that number, right? Then that means we're looking at very big positive or negative values, and so we're going to get 2 intervals, not just 1. Right? This is an or situation. The blue situation is and. The blue situation is an inequality like this, where we've got some value, we're going to end up with some value of x that's greater than some lower limit and less than some upper limit, right? But the red situation ends up giving us an or situation. And think about the graphs. The red graph looks like oars on a boat, right? You see what I'm saying? So the oars on the boat go with the or, right? Okay. So what do we do with this then? How do we solve problems like this? Okay, so all we got to do is if we ever get a situation where we can isolate the absolute value and it's less than a number, we just make this trade. Whatever started off in the middle of the absolute value goes in the middle of the and inequality, right? And the positive value of C goes on the right, and the negative value goes on the left. So it's pinched between positive C and negative C. And obviously, what if this were an equal sign? How would I change it? Then I would put equal signs there and there, right? If it was greater than or equal to, less than. Okay, so let's look at an example like that. So let's try. Yeah, let's try this guy. No. Okay, this one. All right. Okay, what about this? What about this? Is that ready to make a trade yet?
No, it is
It's not. What do I have to do before I make the trade?
Add a 10.
Good. Add 10. Everybody agree?
Sir.
Okay. So now we're ready for the trade, right? We've got an absolute value inequality where we've got an absolute value is less than a number, right? So this is the one that gets the special double inequality, right? If you look back at this sheet, notice that when we do equations, we get an or situation. When we do this kind of inequality, where the inequality is greater than something, we get an or situation. But the one that's different, the one that's special, is the one in the middle. That's the one where we have an inequality that's less than something. So which one is special? The one that the inequality points at, right? There's a way to think about it. So the inequality is like an arrow pointing at the one that gets the double compound inequality, right? The special one. So then if we go here, how are we gonna rewrite this then? What happens to the argument of the absolute value?
Goes in the middle.
Goes in the middle. We won't even worry about what it is yet. What goes here and here?
Positive 8.
And
Negative 8.
and then
Less than or equal to.
yeah, then we've just got, just like we always would with compound inequality, we're always going from the lesser to the greater. And so the inequality signs on a compound inequality, and you've probably gathered this by now, they always open up to the right, don't they?
Yeah.
Go from lesser to greater. And then what goes in the middle, it turns out is 2x plus 6. Now this looks a little weird. What do we do there? Now we're used to isolating x in an equation, or maybe even an inequality, but in a compound inequality like this, where there are 3 parts of the inequality, what do I have to do to get the x by itself? What do you think, Kenny?
Add 6 equals 6.
So what am I gonna do?
Add 6 equals 6.
Add
So
6?
add 6 to 8, or add 6 to negative 8.
Do I wanna add 6 to
Or
it?
minus.
Subtract 6, right?
Subtract 6 equals 6.
Yes. Okay, everybody, now hold on. Everybody focus. This is, you just gotta really discipline yourself to just focus for a little bit, and then you'll have this, and it'll be so easy. Okay, if I wanna get that x by itself, the first issue is to subtract 6, right?
Yes.
But I have to do it everywhere, all 3 places. So that goes away, right? Now I've got 2x in the middle, I've got 2 there, and I've got what, negative 14 there?
Yes.
And then last step,
Divide by 2.
divide everything by 2. So that gives me x. On the left side, I get negative 7. On the right side, I get 1. Does that seem reasonable? That's possible, right?
Yes.
It works. X could be greater than or equal to negative 7 and less than 1, couldn't it? Okay, good. Let's try it. Okay, so on here, I would just go negative 7 x and 1, we said?
Yes.
Okay, got it. All right, let's do one of the other type. All right. Okay, how about this? This is a good one. Let's try this one. Okay, here we go. We're doing this guy.
No,
It's the bottom one. Bottom. All right, so is this one ready to trade?
Yes.
It is. It's ready to trade. We've got the absolute value by itself. Now, what kind of trade do we make here?
Is less than.
Okay, this is the, we haven't talked about this one, have we?
no.
Let's go back and talk about this one. So this is the bottom one. Okay, bottom one. If we have an absolute value of an expression is greater than a number, the trade we make is this. Whatever's inside the absolute values is either going to be greater than positive c, so it's going to be really big and positive, or it's going to be less than negative c, so it's really big and negative. It's going to be extreme. Extremely positive or extremely negative, right? Okay? So, how about here then? What do we get? Ty, what do we get here? What's my trade? So what's inside is what? So whatever's in the bubble, what's one thing it would be?
Negative 2. That's 22.
Say it again? But what's going to be true of that? Okay. Yeah, I thought maybe you weren't paying attention. How about this? Somebody help him out.
48.
Okay, greater than 28, or,
Less than negative 28.
good, whatever's inside the absolute values is less than negative 28. Okay? Okay, so now pay close attention, because there's something here that's gonna be a little tricky that you gotta be aware of. I'm gonna remind you about something. So what are the two steps in order to get the x by itself?
Minus subtract.
Subtract 22 is the first thing. Okay, so minus 22, and that gives us 6 and negative 2x. What's next? Okay, divide by negative 2. No big deal, right? So that's going to give me over here a negative 3, and over here it's going to give me an x. But what do I have to do? Good. If I'm dealing with an inequality, if I ever multiply or divide both sides of an inequality by a negative, remember that means you have to flip the inequality sign, right? You have to reverse it. So because this is negative, when I divided by a negative, that means that that sign has to get reversed.
What if you're dividing by a positive?
Then it'd be fine. Dividing by a positive wouldn't change anything. It's only if you multiply or divide by a negative, right? So then we get this answer. And over here we can do the same stuff, right? I subtract 22. And I get negative 2x is less than, what, negative 50?
No.
I'm going to divide both sides by negative 2, which gives me an x, positive 25, and I've got to flip the sign around. Now look at the results. This is the kind that would have to be like oars on a boat, right? If I graphed it. We'd have to have, so did it work? So let's say this is 0. So I've got x is less than negative 3, right? So it's going to be like that. Or x is greater than 25. So if that's 25, it does look like oars on a boat, so it'll work, right? If I hadn't have flipped it, though, if I hadn't have flipped these, it wouldn't have looked like oars on a boat. It would have been wrong. Okay? Make sense? Yes? Because I divided by a negative. If you multiply or divide both sides of an inequality by a negative number, then you got to reverse the inequality. Otherwise, you don't. You just leave it alone. Leave it alone. Yep. Okay. We good? You want to try this?
Yay.
Okay.